All right. Okay. So Wiley homework number 18 says consider the expected splitting of signals of signal B in the proton NMR spectrum of N methyl 1 propamine, it's an amine, shown below. So presume that JAB is sufficiently different from JBC and that the instrument has sufficient resoluting power. What is the theoretical? Okay, that word theoretical is key. Multiplicity of signal B. Alright, so here's the molecule. There's the N. Alright, so this is E, this is D, environment C, environment B, environment A. So, we're looking at environment B. We want to know what the splitting should be. Now, quickly want to Alright, so when they're talking about this JAB and JBC up here in the problem, they're talking about something called the coupling constant. So they're talking about this AB and this BC. So coupling constant, it says, so on page 410 in the Solomon's textbook, it says, signals from coupled protons share a common coupling constant value. Coupling constants are determined by measuring the separation in hertz between each peak of a signal. A typical Weissenel coupling constant is 6 to 8 hertz. We show how coupling constants are measured. Coupling constants are also when drawing splitting trees. Okay, coupling constants are also used when drawing splitting tree diagrams. So to make a long story short, the coupling constant, the coupling constant between, this is a methyl group right here, right? And this is a CH2. So the coupling constant between A and B, when B is split by A, because it's CH3, it's going to make a quartet. When B is split by C, there's 2 here, so it's going to become a triplet. Now, what we're dealing with here is something on page 412. The book calls it analysis of complex interactions. So what happens, prior we were just asking for coupling constants of environments that were only next to one hydrogen group. So basically what the book explains, when you have an environment that's in between 2 different coupling constants, when it's in between 2 different coupling constants, how do you split that? And there's the theory there's the theory, and also the theory applies, I think, if you have a machine that's very high resolution. And then there's what you actually get if you have a lower resolution machine. And I asked the teacher to explain it, and she couldn't really explain why this happened in class. But okay, so the theory is that A would split B into a quartet. C would split B into a triplet. So when you have that, you take the quartet, you take the higher, and you split each of the quartets into triplets, which gives you 12. So this would give you a quartet of 4, right? And this would give you a triplet of 3. So you multiply them together, and you should get 12 signals. Okay, that's the theoretical. Okay, theoretical. However, this is theoretical, or if you're using high resolution that can see that. Now, what doesn't make sense to me, this is the answer in Wiley, but what on the test, if it's not high resolution, what it says, it is unlikely, however, that we would observe, this is page 414, it is unlikely, however, that we would observe as many as 12 peaks in an actual spectrum because the coupling constants are such that peaks usually fall on top of peaks. The proton NMR spectrum of this molecule is typical of one substituted propane compounds, blah, 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 blah. Hence, by the n+1 rule, we would see that the protons are split into 6 major peaks. Whoa, wait. 6 major peaks. Alright, so then what they're saying here, what you would actually get, you would count in this instance. So if they're asking for the theoretical, it's 12. But what you're more likely to get, count up, you have 3 here, you have 2 here, so that's 5. These 2 hydrogens are surrounded by 5 heterotopic hydrogens. So then it's 5 plus 1, which becomes 6. So this is, actual / low resolution. Use the n+1 rule for all of the hydrogens. So that would give you 6. That's not the answer, but that's just something I think that's good to know, right? I'm sorry if this stuff is like hard to read. Again, I'm going to be putting up these scans in the group.